We're going to look at probability where outcomes are not equally likely, and we're going to visit the scenario of the pregnancy tests and what causes them. A false pregnancy test result is when the test says you are pregnant, but actually you are not. This very rarely happens. False positive pregnancy tests are rare, but they can occur. So now let's determine how accurate are pregnancy tests. Can I get a false positive? Home pregnancy tests are becoming more and more reliable, but there is still a small chance of error associated with them. Home pregnancy tests are 97% accurate. So that is why we put 97% on the accurate branch. And of course, this has to add up to 100%. So therefore, 3% is inaccurate. Now remember, 3% is 3 over 100, and if you put it on your calculator, will be 0,03, which is a very small chance. But normally people want to have 2 pregnancy tests just to check the accuracy of it. So what has happened when you do the second test? So either you can get an accurate outcome or an inaccurate. Now remember, what we put on this branch, we're going to duplicate and put on the bottom branch. So you do your thinking in the top branch, and then you just go and duplicate it on the bottom branch. And when we have a look, our let's just get rid of this. So what we are looking at here, how did we get this value? Well, you got accuracy, so you follow this branch, accurate, and then you go along that branch, accurate, accurate, and you will take the values of each of those to work out the probability. And if you multiply them together, now you can see I've changed the percentage to a decimal, so that is the chance that you will get an accurate pregnancy test, positive pregnancy test. Now what happens, let's have a look over here. We get our first one's accurate, the second test is inaccurate, and so for this we are still unsure, because am I pregnant or am I not? And the same occurred here, but this outcome was first inaccurate, then accurate. So what is the result? So in order to be more sure, we go and do it a third time. So we do the test a third time, and from this you can see all we've done is we have added another branch to the top branch. So we have 2 outcomes. It's either accurate or inaccurate, same percentages, although they are different. And I'm going to take this and I'm going to duplicate it to each of the following branches. Right, and then we have a look at our outcomes. So in this case, we're going to go accurate, 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 which gives me that. The next one, I go accurate, again accurate, and then inaccurate. So that is how I got the second one. The third one, you are going to go accurate, inaccurate, accurate. So that's how we got that outcome. And so you would follow the same process through all of them, and to calculate the probability of accurate, 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 you take the percentage on each branch, multiply it together, and that would be your rounded off value. So when we are working out the probability, we are going to multiply the results. And over here, you will see the probability of getting an inaccurate result or a false positive is 0,0003, which is very, very slim. Let's look at another example that is a little more it's not as cluttered. A bag contains 3 black balls and 5 white balls. Paul picks a ball at random from the bag and replaces it back in the bag. He mixes the ball in a bag and then picks another ball at random from the bag. So the first thing we're going to do is draw the tree diagram to represent this scenario. So his first draw, there are 3 black and 5 white. So in total we have 8 balls in the bag. 3 are black, so it's 3/8 are black and 5/8 are white. But then he draws a second time. So all we do is we repeat that on the first branch. And remember, what you repeat on the first branch, you repeat on the second branch. So he's done a draw 2. The next thing we have to do is we have to fill out the outcome. So I'm going to go black, black. So my outcome is going to be black, black. Or I could have black, white, black, white. Or white, black, or white, white. So once you've filled out the outcomes, we are now going to calculate the probability. So what we do is you are going to take each value on those branches. So here it would be 3/8 multiplied by 3/8. And remember, 3 3s are 9, 8 8s are 64. And you would repeat that for each of the branches, and you would get that set of probability values. Once you have done that, you can use the probability in your tree diagram to answer the questions. Right, the first one, use the tree diagram to calculate the probability of picking 2 black balls. So in other words, this is what we're looking for. So the probability is 9/64, which you need to write as probability of black, black will equal, now you're going to take that value, 3/8, multiplied by 3/8, and that would equal 9/64. So that's just the way of doing what we explained previously. Now, what is the probability of a black ball in his second draw? Now, this is where it is much easier to go and see what is happening in the table than having to remember, do I add or do I multiply? So we are looking for a black in the second ball. Here's a black second. Here's a black second. So I could get 9/64 as well as 15/64. So what is my total going to be? 9 and 15 is 24/64. Right, how do we set that out? So the probability of second black will be, the first one we had was 9/64 plus the second one was 15/64, and that would give us a total of 24/64, which you have to simplify, and that will give you a value of 3/8. Remember, when you have a fraction, it always has to be in its simplest form. For more practice with tree diagrams, please have a look at exercise 1, exercise 2, and the summary and questions as seen below in chapter 10.